Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome you all in PIST Virtual Learning System session 2020. Dear students, this lecture is for grade first year, subject computer science, and this is our chapter number 3, Central Processing Unit CPU. And today we will continue Central Processing Unit with CPU operations, instructions, types of instructions, and instruction format. So today we will discuss all these topics in detail, inshallah. So let's start with CPU operations. CPU is the main component of a computer system which carries out the instructions by performing the basic arithmetical, logical, and input-output operations of the system. The fundamental operation of most CPUs is to execute a sequence of stored instructions called a program. The program is represented by a series of instructions that are kept in some kind of computer memory. There are 4 steps that CPU use in their operation. These are fetch, decode, execute, and store. So dear students, in previous lecture, we have already discussed about the CPU and the working of the CPU. So we know that the CPU is the main part of our computer system. Actually, it is a brain of our computer system which is used to control all type of operations and control all the activities inside the computer system. It consists of three main units like CU, AU, and memory unit. And further, it consists of cache memory, registers, and all input-output devices are connected with CPU. So when we talk about the program, every program is executed by the CPU. So when we talk about the program, so program is a series of instructions given to the computer for the execution. So when we enter an instruction and series of instruction, that is called a program. So this program execute a specific task, specific instruction. So CPU is responsible, and there are 4 steps to execute each instruction. First of all, it decode the instruction. First of all, it fetch the instruction, then decode, and then execute. Here you can view from RAM, data will fetched into the control unit and the CPU. This is the step 1, the fetch the instruction. It will fetch the instruction. Control unit is responsible to fetch the instruction from the main memory or from IO devices. Then it passed to the decode unit for decoding. Decoding means to translate your instruction in that format in which the execution unit can understand it easily. Afterwards, it passed to the execution unit, and execution unit will execute the instruction with the help of ALU, arithmetic and logic unit. ALU is responsible to perform all type of arithmetical and logical operation. So there are 4 steps that CPU use in their operation. These are fetch, decode, execute, store, and then again fetch, decode, execute, and store. So it's a cycle, like a cycle. Every time CPU fetch the instruction, then execute, and then store and send back to the main memory. Now, what is an instruction? An instruction is an order given to a computer processor by a computer program. At the lowest level, each instruction is a sequence of zeros and ones that describes a physical operation the computer is to perform, such as add, and depending on the particular instruction type. The specification of a special storage areas called registers that may contain data to be used in carrying out the instruction, or the location in computer memory of data. So in general terms, when we talk about the instruction, so instruction is an order given to a computer processor, which is executed by the computer processor. So when we click and we select anything, that is an instruction for the computer. When we write anything, we open any file, that is also instruction for processor. So this instruction is executed by the CPU, but remember that it must be converted into zeros and one with the help of decode unit. Then the computer can understand, and maybe it have to perform addition, subtraction, any kind of operation. So it must be translated in the form of zeros and ones. So instruction is an order given to a computer processor by a computer program, how to do, what to do. It means that how to do and what to do, what kind of instruction, what kind of work computer and the microprocessor will perform. So what is an instruction set? The complete collection of instructions that are understood by a CPU, known as machine code and machine instruction. It represented by the binary representation. So always remember that whenever we will enter an instruction, computer cannot understand our instruction. Till then, it can be converted into binary number and zeros and ones. Usually represented by assembly codes, user becomes aware of registers, memory structure, data types supported by the machine, and the functioning of ALU. So basically, instruction set must be converted into the machine code and machine instruction. It represented by the binary representation must be converted into zeros and ones. So an instruction or instruction code is a group of bits that tells the computer to perform a specific operation. Instructions are stored in the main memory, waiting to be processed by the processor. An instruction basically is classified in two parts. An instruction is a command to the microprocessor to perform a given operation on a specific data. An instruction consists of two parts, opcode and operand. Operation code stands for opcode. Operation code is opcode, which specifies what operation to be performed and data to be operated on, called the operand. Example, for example, move A, B. So here move is opcode and A and B are operands. Operands means the data on which operation will perform. Opcode is a operation. So here move is a opcode, move is a operation, and A and B is a memory location and operands on which move operation will perform. So operation code which represent the action that the processor execute. Operation code is the action that the processor execute. And operand code which defines the parameter of the action. The operand code depends on the operation. It can be data or a memory address. So it can be a direct data or maybe a memory address. So modern computer supports many types of instruction. We have different types of instruction in our modern computers. First of all, data transfer instruction. These are the types of instruction. So remember that instructions are used for specific tasks. It's an order which is handled by the computer processor. So we have different types of instruction. First of all, we have data transfer instruction. Another type is data processing instruction. The third one is program control instruction. So these three are the types of instruction, basic types of operation. So first type of instruction is data transfer instruction. These instructions move data between registers or between memory and registers. So these instructions basically are used to transfer your data, move your data between registers or between memory and register. So data transfer instruction, basically its purpose is to transfer your data from memory location, between memory location and between register. These instructions copy data from source to destination. While copying, the contents of source are not modified. When you are copying the data, so you cannot modify your data. These instructions transfer data one location in the computer to another location without changing the data content. The most common transfers are between register and memory, registers and IO, register to register. Examples of some common data transfer instructions are move, MOV. This is a data transfer instruction, move. And then we have MVI, move immediate, LDA, load accumulator directly from memory, STA, store accumulator directly in memory, LHLD, load H and L registers directly from memory, SHLD, store H and L registers directly in memory. So these are some data transfer instructions which are used to transfer your data from one memory location to any other memory location, and it can be registers and memory, registers and IO, and uh, register to registers. So here we have one move instruction, how it can use. So move destination and source. So this is your operation. This is your operation. And here then we have the destination address and source code. So operation code means that opcode. This is your operation opcode. And this is your operand on which instruction, data and operation will perform. Okay, destination address and source address. And this is your one data transfer instruction. Now here we have registers name AX and BX is a name of a register. This is your operation move data from source to destination, from BX to AX. So it will move from BX to AX. Your data will move from one register to any other register like AX. Then move some EAX. So some here it will store your data from one register to any other memory location. Move EDX, ARY array, and this is the location of array and the size of an array. So these are the some common examples of move. So move is operation, and then we have operand on which your data will perform the instruction. So data processing means that they are move automatic logic comparison and multiply instructions. Most data processing instructions can process one of their operands using the barrel shifter. Journal rules, all operands are 32 bits coming from registers or literals. The result, if any, is 32-bit and placed in a register with the exception for long multiply, which produce a 64-bit result. Three address, it can follow three address registers. Data processing instruction, largest family of ARM instruction, all sharing the same instruction format. It contains the automatic operation, comparison, logical data movement between registers. So data processing instruction basically is used to transfer your data, and the movement instruction between the register and between the memory location. Remember, this is load store architecture. This instruction only work on register, not a memory. The each perform a specific operation on one or two operands. So first operand always a register, second operand sent to the ALU like a barrel shifter. So here we have a source and the destination addresses. Then first of all, we have an operation like store. Then we have a memory location and the register where the operands operation will perform. Data processing instruction. The processing instruction all use a shifter operands. Mnemonics can be used, okay, like RD, RN operation, shifter operands. The non-destructive instruction will not use a destination register. Some instruction reserve the operands order. Move is the data processing instruction without RN. Since shifts can be part of any data processing instruction, there are no dedicated shift instruction. Then we have logical instructions. Logical instruction is Next is data processing instruction. So data processing instruction, these instructions are related to the arithmetic and logic operations. The arithmetic or logic operations are performed on the values of two registers, and the result is also placed in a register. Data manipulation instruction can be divided into three basic types. So data processing instruction can be classified in arithmetical and logical instruction. So it can be classified in three types. The first type is arithmetic instruction. Then we have logical instruction. Then we have shift instructions. So basically, data processing instructions are responsible to perform data processing with the help of arithmetical and logical and shift instruction. So let's continue with the help of logical and arithmetic instruction. Logical instructions are basically instructions perform various logical operation with content of accumulator register. The logical operations are AND, OR, XOR, rotate, compare. So logical instructions are used to perform logical operations, comparison and logical operations. So like AND operator is used to compare two values. If the both values are true, then result will be true. In the case of OR, if one value, suppose you have a two value, if one value is true, then your result will be true. So this is a logical instruction which is used to compare the value and perform the logical operations. Then we have arithmetical operations. Arithmetic instruction, there are 24 arithmetic opcodes which are grouped into following types. So first of all, arithmetic means that mathematical instruction, all type of mathematical operations. Like these instructions are used to perform arithmetic operations and can be classified in different categories. We have different mathematical functions like addition, subtraction, multiplication, division. So ADD, add, this is a mnemonic, and the short word of addition, SUBB, sub, this is subtraction mnemonics, and the short word MUL for multiplication. This is division, increment, decrement. So all these are the basic arithmetic opcodes which are used to perform the operation on data and the registers. So basically, these are all mathematical function. Arithmetical unit and arithmetical instructions are responsible to perform mathematical functions. So here the next type is program control instruction. This is the third type of your instruction. This is program control instruction. So program control or transfer control is a way of altering the order in which statements are executed. There are a number of instructions used for this purpose like jump, loop. So these are program control instruction. So program control instruction, specific instruction to generate software interrupts. There are also interrupts that are not part of the instruction set called hardware interrupts generated by devices outside of a microprocessor. Exceptions and traps are triggered when valid instructions perform invalid operations such as dividing by zero. Halt instruction cause the processor to stop execution such as the end of a program. So program control transfer instruction basically is used to transfer the control and the disturb and interrupt the sequence of your execution. We have different program control instruction like branch, BR, jump, JMP, skip next instruction, SKP, call procedure, call, return from procedure, RET, compare by subtraction, CMP, test by ending, test. So these are typical program control instructions which are used to control your program with the help of these codes. So dear students, now I'm going to talk about Instruction format. An instruction format or instruction code is a group of bits used to perform a particular operation on the data stored in computer. Processor fetches an instruction from memory and decodes the bits to execute the instruction. Different computers may have their own instruction set. So an instruction format defines the layout of the instruction. The instruction format basically is used to define the layout of the instruction. It consists of two parts, an opcode and operand. Opcode and operand, which we have already discussed in the previous slide, that opcode is an operation code and operand is operation. So here an instruction is normally made up of a combination of operation code and some way of specifying an operand, most commonly by its location or address in the memory. So here we can check the opcode, that is the operation. We have checked many operations like move, LD, add, store, all these are the operation opcode, and then we have an operand on which your instruction and the data will perform the operation. So this is your instruction format, which can vary, and we have different addresses of these instructions which we can use to execute the instruction. So instruction format, two major components of an instruction code: the operation code, opcode, and the address. And opcode specifies the operation for the instruction, and address specifies the register and or location in memory to use for that operation. So here we have a addressing mode. This is your addressing mode. Then we have a opcode operation, and here we have an address on which this operation will perform. This is a simple instruction format and the basic instruction format, but we can classify our instruction format into different categories. When instruction has two components, opcode and operand, add, and this is R0 and 100, maybe a register address or maybe a direct data. So we can classify the operand field may have the following format: 0 address instruction, 1 address instruction, 2 address, and 3 address instruction. The total number of instruction and the type and the formats of the operands determine the length of an instruction. So we can classify instruction format in 0 address instruction, 1 address instruction, and 2 address instruction. So first of all, instruction format, we have 0 address instruction. Here 0 address instruction, 1 address, 2 address, and 3 address instructions. 0 address instruction. In 0 address instruction, there is only one address and memory location. There only one. So 0 address instruction basically format requires only one opcode. Here you can check in A, here is only one opcode. This is 0 address, means that there is no address is required. This is only operation code. So 0 address instruction format requires only opcode having no operation to work with. So 0, example of the 0 address is halt, stop, push, add. So here we have only 0 address, means push A, push B, add, push C. So this is TOS, is a top of stack. This is top of stack, and with the help of this add, push, we can use without any address. We are just giving the instruction. Okay, so this is 0 address instruction. Then we have 1 address instructions. 1 address can be a register, name, or memory address. Single accumulator organization, it uses AC register for all data manipulation. Like suppose add X. Add is a mnemonic and the operation X is a register. So micro operation AC plus MX. So here we have a accumulator register that is used to hold one memory address and transfer your data. So 1 address instruction format requires 1 opcode and 1 operand. Remember that here we have 1 opcode and 1 operand. Example of 1 address instruction format is LDA, load accumulator, jump. These instructions requires 1 address to do the operation. So like jump is used to require one address in order to jump, so that specific address location. Load instruction is used to load your data, and jump instruction is used to jump your instruction from one location to any given and specific location. So use and amplify AC register for all data manipulation program to evaluate. So load, add, store with the help of only one registers. Then we have a to address instruction. To address instruction or two memory locations are specified. Assume that the destination address is the same as that of the first operand. So instruction add R1, R2. Micro operation R1, R1 plus R2. Here we are using the same register and plus R2. The value of the R1 plus R2, and then again storing in register R1. It will update the value of the register R1. So this is to address instruction in which we have two memory addresses. We have two memory addresses. So to address instruction format requires one opcode and two operands. It requires one operation code, one opcode, and two memory addresses, two operands. Examples of such instruction format is the move, which moves data from the memory location to the register and from register to the memory location. So this is to address instruction which holds two memory location. Here move R1A. So this is operation move opcode, and here we have a source and destination registers which are used to transfer your data from one location to any other location, and location can be a register or the memory. It can transfer your data from register to memory or memory to register. Now I'm going to start instruction cycle. What is instruction cycle? The time period during which one instruction is fetched from memory and execute when a computer given an instruction in machine language. Each instruction is further divided into sequence of phases. After the execution of the program counter is incremented to point the next instruction. Instruction cycle is the basic operation cycle of a computer to execute various instructions. It is the process by which a computer retrieves an instruction from its memory, determines what action the instruction requires, and carries out those actions. So basically, instruction cycle consists of following operation: fetch, decode, and execute. Here we have a fetch instruction, execute, and increment. Execute the instruction, fetch, decode, and execute. This is our instruction cycle in which we have three options and three operations: fetch, decode, and execute. Three main parts of this process. Fetch means retrieves the instruction that is required to be used. Decode, the instruction is interrupted and broken down into its constituent part, e.g. opcode and operand. Execute, the instruction is performed and carried out. So fetch, decode, and execute cycle, sometimes we can call it instruction cycle, and sometimes we can call it fetch and decode cycle. Fetch. The first operation is fetch operation. In this operation, the control unit fetches an instruction from main memory by sending an address through the address bus and a read command through the control bus. The fetch operation places the instruction into the instruction register IR inside the microprocessor. So fetch means to fetch something, to fetch the instruction, to fetch the data. So fetch operation basically is responsible to fetch your instruction or data from the main memory and bring inside the CPU for the execution. The program counter start at 000. Okay, this is one example. So program counter, here we have a registers, program counter, MAR, MDR, IR, accumulator register. Okay, and here we have a control bus, data bus, and address bus. So program counter start from 0000, this means that the first address in RAM where the computer will look for an instruction is at. A computer needs somewhere to store the current address in RAM that it is looking for. This is what the memory address register MAR is for. 0000 is therefore copied into the MAR. So this is a memory location from the RAM. It is copied into the memory address register, memory address register. The address is copied here, and this is the program counter which indicates which instruction will be fetched the next. Then we have a decode. Decode means in this step the instruction decode. The instruction decoder decodes the instruction to determine what the instruction is intended to do. Decode means to translate the instruction, what operation it wants and what operation performed by the execution unit. So the instruction fetched, and all after fetching it is decoded and converted in that format in which the execution unit can understand. The instruction need to be decoded. It is sent via the data bus to the control unit where it is split into two parts. The first part is the operation code or opcode, which in this example CPU is the first 4 bits. This is the command that the computer will carry out. The second part, in this case, the second 4 bits in the operand. This is an address in RAM where data will be read from or written to depend on the operation. The control unit can translate opcodes into instruction. So here the control unit translate the opcode 0101 into a load from RAM. So here instruction is translated, converted, and data is loaded into MDR. Then we have a execute. The third operation is execute. Execute operation, once the instruction has been decoded, it can be executed. In this operation, the timing and control logic circuitry in the control unit generates signals needed to execute the instruction. The instruction may perform automatic, make a decision, simply move data from one memory location or any other memory location. So execution responsible, execution instruction basically, an execution unit is responsible all type of execution. It can be automatical, logical, and data movement. Now the command will execute it. The operand is copied to the MAR as this is the address of the data that needs to be loaded. The data at the address 0100 is then fetched from the RAM and passed up data bus to the MDR. As it is an instruction but simply data, it is then passed to the accumulator register. So these three are the operations of instruction cycle: fetch, decode, and execute. And after execution, we need to store our result. So this is a fetch data and instruction. First of all, your data will fetch from the memory and from any storage location or from any peripheral devices and IO devices. After fetching the data, your instruction or data will pass to the decode unit. It will decode the address, it will decode the instruction, and then pass to the execution unit for the execution. Execute unit and execute command then execute according to the required data and instruction. It will perform the operation like mathematical operation and logical operation. Which operation is required, it will be decided by the execute unit by looking at the code of given on the instruction. So it will check the opcode, operation code, and then check the operand and perform the instruction according to the required operation, and then send back to the memory location for the storage or IO devices. So this is a complete machine instruction cycle and fetch, decode, execute cycle. Sometimes we can call it machine cycle, sometimes we can call it instruction cycle, and other way we can call it fetch, decode, and execute cycle. And this is a very important cycle which is used to execute each and every instruction inside the CPU. Thank you so much, students. Inshallah, in next week, we will continue the last topic of this chapter, inshallah. Till then, Allah Hafiz.